And this small device changes the way that we perceive our world and the way that we interact with our world. What I'm going to show you today is a new way that we're developing technology to interact with the world for the future. The technology of the brain. Now, the brain is an amazing organ. There are millions and millions of neurons that become active, and they send signals not only to their neighbors, but also to very different parts of the brain. It's a very intricate and elegant signaling of all of these neurons and how they evolve over time. And what we've done is develop the technology in order to sense these signals in real time. And today I'm going to show you a few examples of what that technology is and how it actually came to be. Those discoveries, right, those technologies are opening the door to a whole new set of possibilities for the future. How do we do all of this? So this may be your first time hearing about a direct neural interface. In the middle of the screen up there is actually an example of one of the types of neural interfaces that we're using in humans today. So this is a sensor array. One of the tips on that little array can detect between 1 and 3 neurons in your brain. All right? And we have the technology in order to identify those neurons, amplify their activity. There's minuscule signals actually happening in your brain. You can send those signals into a computer, and that computer can interpret what all of those signals actually mean when you're thinking about trying to do something. And we can place these sensors anywhere in your brain or even in your peripheral nervous system, right? These are the nerves that are outside of your brain. So while you may have thought of neurotechnology, as I've just described to you, as being something way off in the future, it's actually a technology that exists today, and we're actually using it with humans. How did we get here? Okay, so again, I'm telling you about something that you may not be familiar with, but we actually have a history of working in neurotechnology. And it turns out that in the early 2000s, neuroscientists like myself didn't even know if it was possible to read out, let's say, 100 neurons of activity in real time from an awake-behaving individual. So we started in animal subjects. We said, okay, let's try these sensors out. Can we read out the signals in real time? And can we do something simple like control a robotic arm? And we showed that we could actually do that, just having the animal think about it. And once we proved out that technology, in 2005, we said, okay, we're ready to go to humans. Can we place the same technology in the human brain and restore the ability to move and even sense after you've been injured? And I'm going to show you a couple examples of this. And yes, we could do that. And we said, okay, again, this is DARPA. We try to push the limits of what's possible. We said, okay, if we can do that for movement and sensation, can we try to do something even more complex? So we went to memory in the human and said, okay, for humans with traumatic brain injury, could we restore their ability to form and recall memories? Direct brain interface. Now, here's the one thing that may blow your mind. The kind of questions that we have to go after here are answering things like, what is a memory in your brain? Right? Have you ever thought about what a memory is, what those intricate neural firing patterns actually are, and how you need to interact with them in order to facilitate memory formation and recall? That's the scale of the problem that we're actually working on at DARPA. Again, being DARPA, we don't just stop there. We keep moving forward in our trajectory. I actually started a new program in 2013 called Subnets, thinking about the sub-networks of the brain, but for the most challenging problem of neuropsychiatry, and that's mental states, right? Think about depression and anxiety. Think about trying to develop a direct neural interface to help people with their depression and anxiety. And again, the same questions are there. What actually is depression in the brain? What are the neurons that are involved in anxiety? Those are the kinds of things that we're ultimately doing. Okay, so we have a very long trajectory here, right? Over a decade of work in this space. And what I'm going to do next, I'm going to show you some examples of the achievements that we are able to do today, and then paint a picture for you for what the future of neurotechnology may ultimately hold for us. There's actually a freshman in college who was studying nanotechnology. When he heard about some of our studies, said, I want to be a pioneer in that. So he signed up to do one of our studies and had that same array placed in his motor cortex, right, the part that is involved in movement. He had another set of arrays placed in his sensory cortex. Okay? And you can actually see where those arrays are connected to. And the wires send the signals from his brain actually to that bank of a rack of computers, and process all of his neural activity in real time, and actually send that activity to that robotic arm. Robotic arm also had sensors in the fingertips. The force transducers took that information and did the reverse. Went back through the computers, went back through the wire, back into Nathan's head, and he could actually feel the president's hand on the robotic hand. It was truly a remarkable moment. Okay, so that's what Nathan can do. Let me show you a video of something else that Nathan can do. All right? So this is Nathan taking these cones and he's kind of building this structure. He's doing all of this just by thinking about it. You can see he's not moving his own arms. He's just producing the neural signals directly from his brain and stacking those cones. Right? So think of this, right? You're a paralyzed person being able to interact with the world in this way. It can really be transformative for you, right? You have a new way to project yourself onto the world. All right, so Nathan, he was astounded by this moment. It's life-changing for him. But we asked him, Nathan, what else do you want to do? And he's a gamer, and he said, I want to fly an aircraft. So we said, okay, we can help you to fly an aircraft. So the next thing we did is we connected him to a F-35 Joint Strike Fighter and put him out over Las Vegas. And we basically remapped his neural activity onto any control surface that we ultimately wanted to on that Joint Strike Fighter. Put yourself in the place of Nathan. Think about how you're locked in this wheelchair, and then think about your ability to actually control this aircraft, change your perspective of the world, and see it in a very different way. And I think that he sees Las Vegas in a very different way now that he's able to fly over. And Nathan started having a lot of fun with this, and at the very end of this run, he's like, I'm just going to do a barrel roll here, and did a barrel roll in the aircraft. And it just kind of shows you the creativity that a person like Nathan with a direct neural interface, what they can ultimately do. That's what we can do today. What does the future look like with these kinds of technologies? Okay, so think about building with your brain. Think about changing your perspective of the world by flying over a city with the brain. So in this vignette, this person is an architect, is paralyzed, lost control of his arms. He needs a new way to communicate his ideas. So through his direct neural interface, he can connect to his drafting software, position buildings anywhere he likes, the details of the building. Maybe he can even connect to a collaborator out in the field to get a different perspective on the building. Okay? And imagine, in the future, building a skyscraper just with your brain, just with the perspective of your brain. It could be transformative. The next example I'd like to show you is a person, his name is Doug. Okay? And Doug was injured 25 years ago in a near-fatal electrical accident. And Doug's very different than Nathan in the sense that he has no hands on both of his arms. He lost both of his hands. Imagine living your life that way. But for Doug, we also explored the possibility of a direct neural interface for him. So in this particular case, we took that same sensor array, but instead of placing it in the brain, we placed it into the nerves of his forearm. And you can actually see on the right side of the screen there, his residual limb, and that's where that sensor array is. Now, what's different in this picture is that we connected his peripheral nervous system to that 3D virtual environment that's in the center of the screen. And there's a virtual hand there, and it's going to be touching a virtual door. And whenever the virtual hand touches the virtual door, signals are sent back into that electrode array, into his nerves, and this is what Doug can actually do with that interface.
Oh my God, I just felt that roar.
Can you feel the fingers sliding when you do that?
Yeah, actually I can. I can get it on there. God, that is so cool.
And it is cool, right? You can imagine working in that 3D world just through your nervous system. It really is amazing. So when we see something like this, we say, can we change the future? Can we change the way that we even play, right? So imagine in the future you had a direct neural interface, and that direct neural interface gets you off your couch in a virtual way, enables you to explore virtual worlds just through your direct neural interface. And we've got game controllers and cameras that do this now, but it's nowhere near the kinds of things that I'm talking about here. Again, exploring your cognitive space in this virtual world could be transformative. What if you could even connect to your friends all across the globe through your direct neural interface and kind of explore what that would actually be? Okay, so what we're doing today with Doug is just the beginning of what we think is possible in the future.